let's start with question number 15. How many chiral centers are present in a testosterone molecule? Now let's see how many chiral centers are present here. So you must always exclude the ones which are on the corners like this because they will have two hydrogens. Yes. Then this one can't be chiral because it has a double bond. Can't be chiral, has a double bond. Can't be chiral, has a double bond. Can't be chiral, has three hydrogens. Not chiral, two hydrogens. Not chiral, two hydrogens, two hydrogens. Can't be chiral, three hydrogens. Can't be chiral, two hydrogens, two hydrogens. So which ones are you left with? 1, 2, 3, 4, 5, and 6. Yes? So you're left with these. Let's check. This one has one OH, one H. Yes? Then you draw a line of symmetry here. You can see that this side is very different from the other side, which is all of this. So is this chiral? Yes. Then let's look at this one. So this is chiral. Let's look at this one. 1 bond, 2 bond, 3 bond, 4 bond. So one is a CH3. Now one is all of this stuff. Let me highlight it for you. So one is all of this stuff. One is all of this stuff. And one is this. Do you see all of it is different? Yes. I've just made the outline, but you can see all 4 are different. So this is chiral. Then let's check this. If you have 4, the answer is obviously 6. Yeah. So let's check this. It has 3 bonds. One is a hydrogen. So one is all of this stuff. One is all of this stuff. And one is all of this. Yes, do you see it's all different? Put it in a different color for you. You see all of this is different. The one in red, the one in blue, the one in purple, they're all different groups and one is an H. Yeah. So this carbon is also what? Chiral? Yes. Let's check this. It has 3 bonds. 4th is a hydrogen. So one is all of this stuff. One is all of this stuff. And one is all of this. You see, all of this is different. They're all different groups. Yes. So this is also what? Chiral. If you have 4, definitely the answer can't be 1, 2, 3. We've already identified 6 carbons. The answer will be D6. This is also chiral, and this one is also chiral. Clear? Now, what are the least number of carbon atoms in a non-cyclic alkane that has a chiral center? So they're saying least number of carbons that is non-cyclic, which has a chiral center. So let's see 7. With a 7 carbon, can we make a compound which is an alkane with a chiral center? So let's see. See, now you need how many bonds? 4, and all 4 must be what? Different. How many carbons do we have? 7. So let me put one as a hydrogen. Yeah. Let me put one as a CH3. Yeah. Let me put one as a C2H5. How many carbons have we already made? 2, 3, 4. How many are we left with? 3. So you have C3H7. Do you see you have a carbon with 4 different groups and it is chiral? And the minimum number of carbons we need for that is 7. The answer therefore is A. Clear? Understood? Drug cortisone has the formula shown. How many chiral centers are there except the ones that have been marked with an asterisk? So you know the ones that can't be chiral, this, 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 this. These have 2 hydrogens, the rest have double bonds. Can't be chiral, why? Why? 2 hydrogens. Can't be chiral, why? 2 hydrogens. Can't be chiral, why? 2 hydrogens. Can't be chiral, why? double bond. Can't be chiral, 2 hydrogens, 2 hydrogens. Can't be chiral, 3 hydrogens, 3 hydrogens. Can't be chiral. Why? CO is a double bond. Now, can't be chiral. Why? 2 hydrogens. So we are left with 1, 2, 3, and the rest have already been marked as asterisk. Yes? So what will be your answer? D. You see, mostly the ones on the corners are usually chiral. If you want to check, you can. I'm just erasing all of this stuff, and we can check for chirality in the ones which have been highlighted. So let's see. This has one bond, which is all of this stuff. Let me highlight it. So one is all of this. One is an OH. And then you have this bond and this bond. So between these two, we will make a line of symmetry. And you can see this stuff is very different from the rest of this. Do you see all 4 bonds are different? So this is chiral. Yes? This has a CH3, this, and this. So if you see, this is one bond. This is the second bond. Yes? And this right here is the third bond. And the fourth is a CH3. Are they all different? Yes. So this is also what? Chiral? Yeah. And then this one again has 1, 2, 3, and 4. One is a CH3. One is all of this stuff. Yes. One is all of this stuff. Yes. And one is all of this. Do you see they're all different? Where now will be like, Miss, how will we know where these chains end? You don't really need to know, as long as you can just trace them and they're very visibly different. You know that they're all 4 different groups. Yes? Clear? So this becomes how many chiral centers? 3. 3 have already been marked and 3 more. Clear? How many structural isomers are there for trichloropropane? So you have a 3-carbon trichloropropane. Let's see the number of structural isomers. So let's see. C3H5Cl3. How many structural isomers? So you can have no chain isomers here. Why? Because trichloropropane, propane will be the longest chain. You can't have a chain of ethane and CH3 as a side chain. Yes? It will again become a 3-carbon propane. So you have 3 carbons, so 3 Cls, you can put them all on carbon number 1. Yes? So this is what? 111 trichloropropane. Then what else can we have? 112 trichloropropane. What else can we have? 122 trichloropropane. What else can we have? 113 trichloropropane. Very good. So you can have 111, you can have 112, you can have 122, you can have 113. Yes, you can't have a 133. 133 will be the same as 113. Yes. Then what else can we have? 1, 2, 3. Yes. Can you have a 223? No, 223 will be the same as 122. Clear? Any other possible structural isomers? Any other possible structural isomers? No. So there are how many? 5. They haven't asked for stereo. If they would have, you would have looked for chiral centers. Yes? No cis trans, obviously. Why? Because there is no double bond. Which compound does not show cis trans isomerism? 2-methyl-pentuene. So let's make this. So pentuene means main chain has 5 carbons. On carbon number 2, you have a methyl, which does not show. Can this show cis trans? No. Why? CH3 and CH3. Is this clear? So this does not show cis trans. Is this clear? Yes. Diagram shows a molecule that has pi and sigma bonds. How many sigma bonds are present? I told you all single bonds are sigma. In a double bond, one is sigma, one is pi. In a triple bond, one is sigma 2 or pi. So let's see. Here you will have a sigma. This is a sigma 2, 3, 4, and 5 because it's a CH2. Yes. So 1, 2, 3. Let me put it in different colors so we can identify them. So you have a CH2. First, I'm showing all the bonds, so it's easier to count later. Then you have another CH2 here, a CH here, and a CH2 here. Let's see the sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 sigma bonds. The answer therefore is C. Clear? Question number 25. The molecule is optically active. How many chiral carbons are present in this molecule? All right. Can this be chiral? No. Why? 2 Cls. Can this be chiral? No. Why? 2 hydrogens. Can this be chiral? Let's see. So this has a Cl, an H, a C2H2Cl2. Yes. And all of this. And you see all of this has 3 carbons. So it's different from the 2 carbons here and a Cl and an H. So yes, this is chiral. Can this be chiral? Can this be chiral? No. Very good. Why? Because it has a CH2Cl and another CH2Cl. Do you see that? They are both the same. So this can't be chiral. Can this be chiral? No. Why? Very good. Can this be chiral? No. Why? 2 hydrogens. Is this clear? There is only one chiral center. The answer therefore is A. The alkene has a formula CH3CH. All right. So it's a C double bond C with a H with a CH3 with a R with a CH2CH3 and does not possess cis trans. What is R? So when will it not possess cis trans? If these two are the same. So what should R be? R should be C2H5 as well. That is D. Is this clear? How many sigma pi bonds are present? So let me again make the bonds for you. So it's a CH3. Then you have a CH2. Then you have a CH3. Then you have a CH2. Then you have a CH2 here. Yes? Let's count the sigma first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25 sigma bonds. The answer is D. And you see you have 3 pi bonds. 1, 2, and 3. Clear? Menthol is an important compound expected from the peppermint plant. How many chiral centers are in one molecule of menthol? Can this be chiral? No. Why? 3 hydrogens. Can this be chiral? No. Why? 2 hydrogens. Can this be chiral? No. Why? 2 hydrogens. Can this be chiral? No. Why? 2 hydrogens. So you are left with this one. Can this be chiral? Maybe. Can this be chiral? No. Why? 3 hydrogens. Can this be chiral? No. Why? 3 hydrogens. Can this be chiral? No. Why? 2 CH3s. Very good. So you are just left with 2 options. This one and this one. Let's check. This has 1 hydrogen, 1 OH. Make a line of symmetry. You see this side is very different from this side. Is this chiral? Yes. Yeah. So this is chiral. Then we have this one. You have 1 hydrogen. 1 is all of this stuff. And then for the third and the fourth bond, we make a line of symmetry. You see, this side is very different from this side. Do you see all 4 bonds are different? Is this chiral? Yes. How many chiral centers do we have? 2. Yes. Which one? This one? Yes, let's check this. So let's check this one. We have one CH3, one hydrogen. I don't know how we missed this. So this is 1H, 1 CH3. You draw a line of symmetry. This side is very different from this side. Yes, this is also chiral. How many chiral centers? 3. Understood. Yes. Which of the compounds shown have a chiral carbon atom? All right. So none of these can be chiral. We know that. Yes. We can check for this one. So you make a line of symmetry. So this has a CH3 and H. Yeah. So here we have how many carbons? On this side, 2. On the other side also, how many carbons do you have? 2. So are they both the same? Yes. So is this chiral? No. So it can't be A, can't be B. The only thing you need to see is whether 4 is chiral or not. If 4 has chiral carbon, answer is D, otherwise it is C. So let's check 4. This can't be chiral. Why? Double bond. This can't be chiral, can't be chiral, can't be chiral. Why? 2 hydrogens. The only one that we can check is this. This has a H, a CH3. Now you make a line of symmetry. Are they different? Yes. So this is chiral. The answer therefore is clear. Now, which one shows both cis trans and optical isomerism? First, let's find the ones which can show cis trans. The ones that can't, you don't look for optical isomers on those. All right. Can this show cis trans? No, can't be the answer. Can this show cis trans? Yes, can possibly be the answer. Can this show cis trans? Yes. Can this show cis trans? No, can't be the answer. So let's check for optical isomerism in C and B. Can be chiral? Can this be chiral? No, double bond. Can this be chiral? No, double bond. Can this be chiral? Yes, because it has a Cl and an H and a Br and all of this stuff. Do you see you have a chiral center? The answer therefore is B. Can't be C because this is not chiral. Why is this not chiral? Because it has 2 Brs. The rest of the carbons have double bonds. Clear? All right. Which diagram correctly illustrates an optically active trans fat? They are saying R1 and R2 are different hydrocarbon chains. What do you mean by trans fat? Where similar groups are on opposite sides. They are saying R1 and R2 are different. What are the similar groups? H's. Do you see they're on opposite sides here? So which isomer is this? Trans. When H's are on opposite sides, it will be trans. If H's are on the same side, that would be cis. They are asking you for trans fat. So this is cis, this is cis. A and B are trans. Yeah. Now you need to look for optically active as well. So needs to have a chiral center. They've told you R1 and R2 are different chains. So let's see. Can this be chiral? No. Why? Double bond. Not 2 O's, but the 2 O's are bonded via, one is bonded by a double bond, one is a single bond. So double bond, no chiral. Can this be chiral? No. Why? 2 hydrogens. Can this be chiral? No, because R1CO2CH2, R1CO2CH2, they're both the same group because R1s are the same. Yes? Let's check B. Can this be chiral? Yes, because it has an H, it has all of this stuff, and it has R1CO2CH2 and R2CO2CH2, and they've told you R1 and R2 are different. The answer therefore is B. Clear? Which compound exhibit both cis trans and optical? So let's see. First, I will see the ones which can show cistrons. The ones which don't, we can eliminate those. Yeah, I hope we can eliminate some. Yes, we can clearly eliminate B because it has a CH2. So this doesn't show cistrons. Do you understand that? Because the carbon with the double bond has two H's. So it can't show cistrons. Can't be B. Okay. Can't be B. Yes. Now let's check A. So A is a carbon-carbon double bond with a H and a CH3. And it has an H and a CH2CH3. Can this show cistrons? Yes. Does it have a chiral carbon though? No, because this has 3 hydrogen, double bond, 2 hydrogen, 3 hydrogen. Can't be the answer. Yes. Let's check C. So you have Br, CH3, Br, CH3. Does it show cistrons? Yes. Does it show optical isomers? No, can't be the answer. Let's check D. C double bond C, H, Br. Then you have a H. Then you have a H. Then you have a all of this. So then you have a basically a CH3, CH2, C, H, and a Br. So this is what's attached. Now, if you see, does it show cistrons? Yes. Does it have a chiral center? Yes. If you look at this carbon, it has an H, a Br, all of this, and a C2H5. Is this chiral? Yes. The answer, therefore, is D. Understood? Understood? Structure below show isomers of C6H12. Which of these are cistrons of each other? 1 and 2. Let's see. What is in 1 and 2? CH3H, CH3H, CH3, C2H5, C2H5, CH3. Okay. Now, how will we identify the cis and trans? If the same groups are on the same side, it will be cis. Same groups on opposite sides, it would be trans. Are these isomers of each other? Yes. Let's check the others. 1 and 3. Why can't it be 1 and 3? Because in 1 and 3, both are cis. This is also cis. This is also cis. Yeah. Why can't it be 1 and 4? In 1 and 4, these are different. CH3, CH3 here, CH3, C2H5, CH3H here. So they're different compounds altogether. Understood? Yeah. And why can't it be 2 and 4? Because again, they are different compounds. Here, on this carbon, you have 2 CH3s. That's not the case in 2. Yeah. The answer, therefore, is A. Is this understood? Is this clear? Which compound exhibits stereoisomers? Now, they haven't specified whether they want chiral or geometric. Let's see. So you have a CH3, CHCl, and a CH3. Does this have any type of optical isomerism or stereo or geometric? No geometric, no double bond. No optical either. Why? Because this carbon has 2 CH3s. Very good. So this can't be optical nor geometric. CH3, CHCl, CH2Cl. Can this be chiral? No. 3 hydrogens. Can this be chiral? Yes, because it has a CH2Cl, CH3Cl, and a hydrogen. Is this chiral? Yes. Let's see. C, CH3, C, Cl2, CH3. Any optical isomers? No. CH2, Cl, CH2, CH2, Cl. Any optical isomers? No. We've already figured out the answer is B. Diagram gives skeletal formula of 2-bromopentan for all. Technically, the naming is wrong in this question. Yes, 1, 2, 3, 4. I'll tell you why. 5. So you have a 2-bromo pentan 4-ol. You know, when we number in such a way that the most important functional group gets the least number. It should be 4-bromo pentan 2-ol. So there's a mistake in the question here. Yes. So it should be 4-bromo pentan 2-ol. And what will that be? 1, 2, 3, 4, and 5. You have an OH over here, or you can take this as carbon number 2, whatever. Yes. So you have OH here, Br over here. Yeah. So either you can take it this way, or you can take carbon number 2 as this and bromo as this. So what is the answer? A. Clear? These are 3 structural isomers with the formula C5H12. Which formula correctly represents these structural isomers? So let's make structural isomers of C5H12. So this is what? Pentane, that is a CH3, CH2, 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 CH3. Then you have what? 2-methyl butane. Yeah. So this is a CH3, or can I say CH3 twice attached to a CH? Can I say that? Do you see there are 2 CH3s attached to a CH? Yeah. Can I write it like this? Yeah. Then you have a CH2, CH3, or you can write it like this. CH3, CH bracket, CH3, CH2, CH3. Yeah. Then you can have the third isomer. Can you have a 3-methyl butane? No, that'll again be 2-methyl butane. So then you shorten the chain and you make what? Make what? 2,2-dimethyl propane. I can write this as CH3 4. Can I write it like that? 1, 2, 3, 4 attached to a carbon. Or if you want, you can write it as CH3, C bracket CH3 twice and another CH3. Yeah. These are the structural isomers. Do you have any others? No. Now let's see the structural formulae. CH3, CH2, 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 CH3. Yes. Yeah. This is pentane. Then there is CH3, CH2, CH, CH3, CH3. No. You should firstly have put it in the brackets. Yeah. So if you have a CH3, so yeah, no, this is wrong. Do you understand that? Yeah. If there were 2 CH3s, either you could have put them both together, put a 2 here, or if it was appearing in the middle of the molecule, then this one must have gone into a bracket. Yeah. So A is wrong. B, CH3, CH2, CH2. Yeah, this is correct. Pentane. CH3, CH2. CH in a bracket. Is that correct notation? No. CH shouldn't be in a bracket. The CH3 should be in a bracket. You understand that? Only more than one atoms and the side chain should be in a bracket. You shouldn't put the C and the H in the brackets. So this is also wrong. CH3, CH2, this is right, pentane. Then you have CH3, CH, bracket CH3, CH2, CH3. Yes, this is correct. Do you see this is the same as this one? CH3, CH3, CH bracket CH3, CH bracket CH3, CH2, CH3. Then this is a C with a CH3, a C with a CH3, a C with a CH3 twice, a C with a CH3 twice, and a CH3. Yes, this is correct. You see, this is the same as this. Yes. And this is your answer. Why can't it be D? This is correct, pentane. Then you have CH3, CH bracket CH3, CH3. This is fine. Then the last one should be this or this. And it is not this, you see? It is not 2,2-dimethyl propane. So this is wrong. The answer therefore is C. Understood? Is this clear? All right, how many chiral centers are in the molecule of this? So let's see, can this be chiral? No. 3 hydrogens. Chiral? No. 2. 2 hydrogens. 3 hydrogen. 2 hydrogen. 2. 3 hydrogen. Double bond. Yeah. How many carbons are we left with? 1, 2, 3, 4, 5. That's it. And 1, 6. 6 carbons. Yes? And this, yes. 1, 2, 3, 4, 5, 6, and 7. Yeah. Now let's see. Let's see the chiral carbons. Are they chiral or not? Usually all the ones on the corners are chiral. Yes. So you have an H, you have CH3, then you have all of this stuff. Basically, we make a line of symmetry. Yes? You don't have an H, actually. You have 4 bonds already. So you have 1 bond, 2 bond, 3 bond, 4 bond. So one is all of this stuff. One is all of this stuff. One is all of this stuff. Yes, you see they're all different. This is chiral. I'm just going to highlight it for you, right? So that you can identify the different groups. Then this one has 3 bonds. 4th will be a hydrogen. So one is a hydrogen. One is all of this stuff. One is all of this stuff. One is all of this. Are they all different? And one is a H. Yes? This is chiral. So this is chiral. This is chiral. Let's check this. This is 1 bond. Yeah. This is the 2nd bond. Second bond. This is the 3rd bond. And this right here is the 4th bond. Are they all different? Yeah. Then this one, it already has 3 bonds. 4th will be a hydrogen. So it has this stuff. Yeah, a hydrogen. Then it has all of this stuff. And then it has all of this stuff. All different? Chiral? Yes. You have a CH3, an H. Yeah. Let's check. So this stuff is different from the one at the top. This is also chiral. Clear? I'm going over each chiral carbon, even though we probably know there's 7, but I'm just showing you how to understand, how to identify them, right? This one has 1 bond, 2 bond, 3, and 4th is a hydrogen. So you know this is 1 bond, all of this stuff. Yeah. Then you have all of this stuff. Then we have all of this stuff. Are they all different? Yes, this is also chiral. Yeah, and then we have this HCH3, make a line of symmetry. Are both sides different? Yes. So this is also chiral. How many chiral centers? 7. Understood. Is this clear? 44. How many chiral centers in cortisone? Can I just do the corners now? Let's see the ones not chiral, not chiral, not chiral, not chiral, not chiral, not chiral. Yes, not chiral, not chiral, not chiral. 2 hydrogens, not chiral. Double bond, not chiral. 3 hydrogens, not chiral. 2 hydrogens, not chiral. How many are we left with? We are left, this also can't be chiral. It has 1 H. It has 1 OH. This is the 2nd bond. The 3rd and 4th would be hydrogens. Yes. So this also can't be chiral. So how many are we left with? 1, 2, 3, 4, 5, 6. Is that it? And 1, 7. Clear? How many total chiral centers? 7. Structural and stereoisomers should be considered. How many isomeric aldehydes have the formula C5H10O? So you don't need to make ketones, yes? So C5H10O, they are saying you need to make isomeric aldehydes. So let's see. The first aldehyde will be a straight chain of 5 carbons. This is what? Pentane. Pentane 1L. Yes. Then you shorten the chain. Make a chain. You can't change the position of aldehyde. It will always be carbon number 1. You put this CH3 here. This is what? 3-methyl butane 1L. You can also have what? A 2-methyl butane 1L. So you have a 2-methyl butane 1L. Yes. Then you further shorten the chain and you make what? 2,2 dimethyl propan 1L. Yes. Any other possible aldehydes? No. Now you got to look for isomers, stereoisomers. Can this be chiral? No. Not chiral, not chiral, not chiral, not chiral. So there's only one isomer of this. Yes. This one. Can this be chiral? No. 3 hydrogens. Can this be chiral? No. Why? 2 CH3s. Very good. The others also can't be chiral. So this also has just one isomer. Can this be chiral? 3 hydrogens. Can this be chiral? 2 hydrogens. Can this be chiral? Yes, a CH3, an H, a C2H5 and a CHO. So this will have 2 isomers. Can this be chiral? No, 3 hydrogens. Can this be chiral? No, 3 CH3s. So this will also be 1 isomer. Total isomers are 5. Where did it go? So the answer is C. 46. How many structural isomers are there of C5H10O2 that are esters, including methyl butanoate? So you have 5 carbon ester. So a 5 carbon ester, C5H10O, O2. C5H10O2. Let's see how many esters can we have for this, right? They're asking you for structural isomers, not carboxylic acid, not functional, all right? So let's see. 5 carbons, you can have what? A 3 carbon acid and a 2 carbon alcohol. So 3 carbon acid and a 2 carbon alcohol. Can there be any difference in a 3 carbon acid be anything but propanoic acid? Can it be anything but propanoic acid? No. Can a 2 carbon alcohol be anything but ethanol? No. There's only one possibility here. And this is what? Ethyl propanoate. Yeah. Then let's take a 4 carbon acid and a 1 carbon alcohol. Now 1 carbon alcohol will always be methanol. A 4 carbon acid though can be butanoic acid or 2-methyl propanoic acid. Yes. So there are 2 possibilities. It can be a 2-methyl propanoic acid or a butanoic acid. So you will get 2 isomers, one with this and methanol and one with this and methanol. Clear? Then you have, so you did 3 carbon, 4 carbon. Now let's do 2 carbon acid and 3 carbon alcohol. Yeah. A 2-carbon acid and a 3-carbon alcohol. A 2-carbon acid will always be ethanoic acid. A 3-carbon alcohol can be propan, 1-ol, or propan, 2-ol. So these will again give you how many esters? 2 different esters. One with propan 1-ol and ethanoic acid. One with propan 2-ol and ethanoic acid. Clear? Now you can have 1-carbon acid and 4-carbon alcohol. 1-carbon acid will always be methanoic acid. 4-carbon alcohol can be, it can be butane 1-ol, it can be butane 2-ol, it can be 2-methyl propan 1-ol and 2-methyl propan 2-ol. How many isomers here? 4. 4, 5, 6, 7, 8 and 9. Total isomers will be, where's the question? 9. And we already accounted for methyl butanoate. Yeah? Is this clear? This is the shortest way to do this. When you have esters, you'll be like, okay, 5-carbon ester. You can have a 3-carbon acid. So you can maybe start with this. 1-carbon acid, 4-carbon alcohol. Now 1-carbon acid will always be methanoic. 4-carbon alcohol can have 4 variations. So these will give you 4 different types of esters. Clear? One of methanoic acid with this, one with this, one with this, and one with this. Yeah. Then you have 2-carbon acid, 3-carbon alcohol. So 2-carbon acid will always be ethanoic. 3-carbon alcohol can be propan 1-ol, propan 2-ol. So that's going to be another 2 isomers. Then you can do, a 3-carbon acid, 2-carbon alcohol. We have a 3-carbon acid, 2-carbon alcohol. 3-carbon acid will always be propanoic acid. Yes. And a 2-carbon alcohol will always be ethanol. So there's only 1 isomer here. Then you can do 4-carbon acid, 1-carbon alcohol. 1-carbon alcohol will always be methanol. 4-carbon acid has 2 variations, a butanoic or 2-methyl propanoic. Total isomers will be how many? 9. Is this understood? Now you'll be like, oh, there's 9 of these and then 10th of the methyl butanoate. You've already accounted for methyl butanoate in these. All right. You've already done methanol and butanoic acid. You've already done 1-carbon alcohol and butanoic acid. You've already accounted for it. Is this clear? Very quickly, guys, let's complete the remaining questions. Where did it go? So 9. All right, 49. How many sigma bonds are present? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Oh, that's a repeated question. Never mind. Okay, aspartame, how many chiral carbons are present? Let's quickly see. Can't be chiral, can't be chiral. Why? Double bond and 2 hydrogens. Can't be chiral, can't be chiral, can't be chiral. This is C6H5. C6H5 is benzene. They have already told you there are no atoms chiral in C6H5. So this right here, now you'll be like, Miss, isn't it C6H6? So it is C6H6, but you attach something here, so it becomes C6H5. Anyway, they've told you no chiral carbons here. So this can't be chiral either. Why? Double bond. So how many carbons are we left with? 1 and 2. Yes. Let's check for chirality in these 2 carbons. So let's see if these are chiral or not. Yeah. One last question, guys, and we're done. So let's see. It has an NH2. It has an H. It has all of this stuff, all of this. Are they chiral? Yes. Let's check this one. It has all of this stuff. It has an H. It has all of this. And it has all of this. Are they different? Yes. Is this chiral? Yes. The answer therefore is 2. Is this clear? Do you understand this? Any questions? No?